Today we're doing lesson 9.4 in the MathLinks curriculum, subtracting integers. If you haven't done the lesson for 9.3, please do that one first, because I'm going to be referring to some of the things that we discussed in that lesson as we go through this one. And as before, I want to remind you that we have positive integers represented in red and negative integers represented in yellow, although in the book the negative integers are represented with blue. In the last lesson, when we were looking at subtracting integers, and we dealt with a question like positive 4 minus positive 3, we used integer chips to basically take off of our balance scale, which was our blue box. So we have positive 4 chips there. I need to take away positive 3. Since there are actually positive 3 chips on the balance, I can just take these positive 3 chips away. That leaves me with positive 1. So I know that positive 4 minus positive 3 equals positive 1. In an example like this one, negative 3 minus positive 1, where there aren't actually any positive chips for me to take away, I would add a positive chip, but keep the balance the same by adding the negative chip that would make it its negative pair. When I've done that, because now I've got one positive chip that I can take away, I can see that my answer to the question is negative 4. But today what we're going to do is we're going to look at a different way of dealing with integer subtraction, and it's through using addition. I want you to take a look at these questions, and I want you to consider this. What happens when we have positive 4 plus negative 3? I start with positive 4 chips. I add negative 3, so 3 negative chips. I have 3 that make my net 0, and I've got positive 1 chip left over. So I know that positive 4 plus negative 3 equals positive 1. Notice the similarity. Let's try it again. If we have negative 3 plus negative 1, I start off with 3 negative chips. I add 1 negative chip, and I have at the end 4 negative chips. Negative 3 plus negative 1 equals negative 4. Again, we have the same answer. So one of the interesting things about integer subtraction is that we can actually turn it into integer addition. What we're doing is we're changing these two signs, and they are becoming the opposite. Subtraction becomes addition, and a positive sign becomes a negative sign, or a negative sign becomes a positive sign, as we'll see in the next example. Now we're going to try the same strategy except with negative numbers, subtracting negative numbers instead of subtracting positive numbers as we did last time. We'll do it the way we did in 9.3. We have negative 5 minus negative 3, and we take off negative 3 because we've got those negative 3 to take off. In the second one, we have positive 2 on our balance, but we need to be able to take away negative 4. So we need to add negative 4 chips to our balance. In order to keep the balance at a positive 2, however, we have to also add 4 positive chips so that the negative chips we added balance out to a net 0. Now we can take away these 4 negative chips, and we're left with positive 6. Like we were looking at on the first slide, we can turn subtraction questions into addition by changing the sign on the integer being subtracted, the one that is after the minus sign, into the opposite integer. So a negative 3 becomes a positive 3. and a negative 4 becomes a positive 4. Addition is often easier for us to do than subtraction, which is one reason why this strategy or this algorithm exists. So negative 5 plus positive 3 we know equals negative 2. We go from the 0 line down to negative 5, and then from there we add 3, so we're going up 1, 2, 3 spaces, which ends us up at negative 2. And positive 2 plus positive 4, again in our number line, we start at 0, we go up by 2, we start from where we ended and we go up by another 4, and we end up at positive 6. In both of these cases and in the other two cases on the first slide, our answer is the same. So subtraction can actually be turned into addition questions. I want you to pause the video and take these notes. Now, in the notes of your math journal, I want you to calculate the problems that are on the screen right now using this strategy. So changing these questions into addition questions. And then you can use either the number lines or the integer chips to check your answers. Do that now and then come back and we'll do it again together. With the first question, negative 2, we're changing this into addition problem, so this becomes plus, and we change to the opposite. Positive 5 equals positive 3. If you take a number line, you have from 0, we go down to negative 2, and then we go up 5 more, 1, 2, 3, 4, 5, and we end up at positive 3. Next one, positive 3 plus negative 6 equals negative 3. Again, if we look at our number line, we have positive 3 plus negative 6. 1, 2, 3, 1, 2, 3 ends up at negative 3. Next one, negative 2 plus negative 3 equals negative 5 in our number line. Negative 2 plus negative 3, we end up at negative 5. And finally, negative 4 plus positive 8 equals positive 4. From 0, we go down to negative 4 plus positive 8, and we end up with positive 4. Now, of course, really what I've done up here is checked the addition problem. I haven't checked to see whether this addition problem would give me the same answer as the subtraction problems that we have learned how to do. So let's check that now. I've labeled the question so that it's easier for you to follow along with each of the balances. So with question A, we start with negative 2. We need to subtract negative 5. That means we need 3 more negative chips, which means we need 3 net zeros in order to keep our same beginning. And then we can take our 5 negative chips off and we end up with positive 3, which was, of course, the answer that we received the first time. In question number B, we have 3 positive chips and we want to take away 6 positive chips, which means we need to add 3 more positive chips. And, of course, 3 negative chips to make our net 0. And then we can take away 6 positive chips. Question number C, we start with 2 negative chips and we want to take away 3 positive chips. So we'll put 3 positive chips on the board along with 3 negative chips to make our net 0. And then we can take away 3 positive chips. And with question D, we start with 4 negative chips and we want to take away 8 negative chips. So we need 4 more negative chips added along with the 4 positive chips to make a net 0. And then we can take away 8 negative chips. So in each case, what we end up with is the same as the answer that we had. Positive 3 here, positive 3 when we do our subtraction. We have negative 3 here and we have negative 3 chips here when we do the subtraction. Negative 5 is here and we've got negative 5 on our balance from the subtraction, and positive 4 and positive 4. We're going to look at a word problem that has to do with subtracting integers. The elevation of a lake is the height of its surface from sea level. The elevation of the Caspian Sea is 28 meters below sea level, so we can represent this negative 28 meters. The elevation of Lake Winnipeg is 217 meters above sea level, so we can represent this positive 217 meters. Calculate and explain the difference between these elevations. Now there's actually 2 different ways that we can look at the difference between the elevations, because we can either start at the Caspian Sea or we can start at Lake Winnipeg. So if we did this on a number line, we've got, here's 0. Somewhere down here is negative 28 meters, and somewhere way up here is positive 217 meters. Now we can look at this in 2 different ways. One is to start at Lake Winnipeg and look down towards the Caspian Sea. One is to start at the Caspian Sea and look up towards Winnipeg. So if we were looking from Winnipeg down, we would have positive 217 minus negative 28. We already know that we can write this as an addition problem instead of as a subtraction problem, which would be positive 217 plus positive 28. When we do that addition, we end up with positive 245, or Winnipeg, Lake Winnipeg, is 245 meters above the Caspian Sea. If we're looking at the Caspian Sea and looking up at Lake Winnipeg, we write it differently. Negative 28 minus positive 217. Again, we can turn this into an addition problem. Negative 28 plus negative 217. The number doesn't actually change. It's still 245. What changes is the sign. But it's not because the distance has changed or the difference has changed. It's because we're looking at it in a different way. The Caspian Sea is 245 meters below, so negative, Lake Winnipeg. And either one of these answers is actually correct. Here are the key ideas from this lesson. First of all, you can subtract an integer by adding its opposite. You change the subtraction sign into an addition sign, and the sign on the number, if it's negative, becomes positive. If it's positive, becomes negative. You can also represent integer subtraction by adding the opposite on a vertical or horizontal number line. When you're finding the difference between 2 numbers, you can actually find 2 opposite integers, depending on whether you start with the lowest number and look up, subtracting the highest, or start with the highest number and look down, subtracting the lowest. Both answers are accurate, but they're phrased differently. If you're starting with the highest number, you're saying that the other number is lower than this much lower than. If you're starting at the bottom number, then the other number is this much higher than the first number. In your journal, please copy down the key ideas and do the communicate the ideas questions number 1 to 4. Thanks.